Thanking our hosts today, bitcrowd, for having us here, for food and location. And I would like to basically ask Max to maybe briefly introduce bitcrowd.
Yeah, hello, I'm Max. I work here at bitcrowd. We are an agency. If you haven't heard of us, we don't do things with cryptocurrency. A lot of people ask me that when they have a name. We do mostly web things. We could also do crypto if you want us, probably. We are also working with Elixir. At the moment, the project that is in motion that is, has to do with co-working spaces. Yeah. Aside that, if you want to work with us, talk to us. If you're just interested, talk to us and enjoy the meetup.
Thank you, Max. One note that I want to say, we are trying to actually live stream the talk. So if you are shy from cameras, try to not be in this area. The agenda for today is, the talk name is different. Yeah, so basically the talk name is wrong, but Glauber will give us some introduction in his pull request that he did for Elixir. And we have lightning talks, so basically if you want to present your idea for a quick 5-minute thing, then come to me, let me know, and I'll give you 5 minutes afterwards to give a quick demo. So, Glauber, feel free to...
No? Okay. So, this is the right title. So, I'm Glauber, and I will talk a little bit like I was working this pull request for the last 2 years. And I will talk a little bit. I hope I don't make you afraid of contributing with the language. The idea is the opposite. So, who am I? I'm Glauber, as I said. You can find me by this nickname. Glauber Campinho is my last name. Yeah. And I'm currently working at Meetup. We do these devices, and we use Elixir in production, and not only for backend, because a lot of people ask, do you do nerves? No, we don't do nerves, unfortunately. Also, we don't only use Elixir, we use Go, Ruby. It's just like in my area and some areas we use Elixir. And so I started learning a little bit about Elixir in 2016. And I started contributing with the language in 2017. I started working because I was unhappy with my job and I wanted to work with Elixir, and was the way that I found to try Elixir out, because like at the time I didn't have a job working with Elixir and I really wanted to try the language, and this was the way that I found to try the language. Was a few tries until I could get the first pull request on. I think I tried 3 pull requests before I even started the first one. I just want to share a little bit the process of contributing to the language. So, what's this talk about? It's just showing how I did this request. It's a little bit like the way that I work is not so organized as it will seem here. It's a lot of going back and forth, but this is the whole idea. And I hope that you see that's like, it's a job that any person can do. Like, I didn't know anything about assertions when I started, and now I understand everything about this thing in the language. And it's a process that you learn about the language while you're doing it. And like a lot of very good, smart people are reviewing your code, so I think it's the best way to learn. And so one thing that I really want to show is that sometimes it's really hard and it takes a lot of time to find the solution, but after you find, it's quite nice because you learn a lot during this process. Like I said, that it took 2 years. Usually it's like 1 week or 2 weeks, but this pull request was longer, and like it was the first one that I'm really proud of it. So I'll talk about it. And I want to share some discoveries, the small learnings that I did. If you are more curious, because the talk is I don't have that much time to talk, so if you are more curious, you can talk to me after about these things. So the first step is like understanding the problem. I go there and like I want to work in something, I have some time, I want to learn. How I find a problem to learn, to work. So I open the issues, there is always some open issues there, tagged with levels, and just read them and see if I think I can do it. This one was opened by, I forgot his name, he's emailing all the time. He did talks before, and he was another guy actually complained that when you do a diff when you do a set receive in Elixir, you get just a big red message. You see here, there is a screenshot later to show, and it's really hard to see what's the diff there. And the other diffs are super nice. So basically, he sent the email there in the mailing list, and José said, yes, it's a good feature, please add, but like, just for you, so just that you know, it's very complex, and probably we won't be able to do this so quickly. And this will require changing a lot, because right now we are just diffing values, and diffing patterns is very hard. So the original tweet is this one. You can see like you have two maps here, and like finding the difference between these two maps is quite hard. I imagine that everyone already saw this in the past. So first, what they actually wanted, like we had this thing, and what they wanted is something like this. So I want to be really able to see very quickly what's happening, right? This is how it's in the language in the 1.9, and how we want to be in the next version. So I also start to go. Yeah, you have like I look at the issue like it's fun, like maybe I can do it. I have to look what people did here. Like let me understand what happened here, what's the history, and see what's going on. So like this guy was trying the issue. He came with idea, like was discussing, maybe I should do this, and this is my idea. Does it make sense? And then, if you see, he started in September. In October, he said, this is actually quite hard, I will not do it. So, like, at the second time that someone says, like, oh, it's hard, maybe it's like too hard to do it. Then after there was another guy in October that also picked up the issue and said, like, oh, I'm looking the issue, I have some idea, I will work on this, and then he describes a little bit what's his idea. I'm just taking the list one because I will talk a lot about lists here. So he basically said, like, if you have two lists, I go in the head of the two lists and I start to compare the head of the two lists, and then I go to the next and compare, and I go to the next and compare until there is no element. So he was describing this for a map, for a list, and with each type of things that he should do. And José said, yeah, this is the idea. And he also spoke about like saving the AST of the pattern that you're talking. So José said, yeah, you are in a good direction, but please remember there are a lot of different type of things that could be there, variables, pins, guards, binaries, and you have to remember all of this stuff. It's not just as simple as it looks. So basically, start work on the diffs, and then you can move forward. So from this whole thing, what I got, the current diff should be completely ignored. I forgot to say, but José Valim says here is the first thing, like completely ignore this diff that exists today. The new diff should be able to solve a pattern and can be really complex. The regular asset that exists already in the language is using the old diff mechanism, so it should work also with the new one. And someone already tried and gave up, and then after the person's working the problem. So why did I pick up this problem even if someone was working on it? Because I saw that was hard, and I actually look a little bit deeper in the code, and then I imagine that if the person gives up in 1 month, I can pick up already because I already know a little bit of the issue. So I actually, usually when I start to work in the issue, I never post that I'm working the issue. I really try to understand if I really understood the problem or not before going. This is my way. I don't think you need. You can just post in the here and say like, I'm picking up the issue, and it's fine. I like to do this process before. So I said like, if he gives up in 1 month or so, I can pick up wherever he stopped. So now I know the problem. I need to understand the current situation to see what I will do with this code, right? So I will speak a little bit about this, but just pay attention that like is some regular like code that like when you start in a new company, you look in the code and you're like, how do I understand this code? What can I do? How can I make sense of this so I can do something about it? So this is my process. Like I went first to Erlang, I started to search for diffs, matchers, and all this stuff, and I found this thing that's the test Erlang to see what cases I need to think about that nobody was thinking. But the tests in Erlang were actually not that complex. They were very simple, just if it works or not, and like there are almost no corner cases. There are very simple cases because for match itself, it doesn't need to get that deep. So I start to look in this file. That's the old diff module, and to understand how the diffs worked in the previous version, because anyway, like I'm replacing the feature, but the feature should still work similarly to the features before. So I start looking, numbers, they just compare, and they compare like strings, so they will show just a small difference between the numbers, the diff inside of the numbers. If you have a string, they will use Myers difference. That's like the editing difference. We'll talk a little bit more about this editing distance. It's not just comparing one by one. If we compare, if you see maps, they will work by key, but they should be changed to work in the new solution, because I cannot have these green things when I'm doing a session. So if I have these equals this thing, these should be all white. They should not be, this should not fail, this should actually work. When I'm talking about lists, I have to remember that inside of the list where I can have other elements that will need to be diff also, so I have to worry about nested elements. If I have a list that has only 2 elements switched, I also need to, like, I don't want to make the full thing red and green. I just want to see the minimal difference, so I also have to use this Myers difference, the editing distance, the minimal editing distance for the list. And I have to care about improper lists. I cannot forget that there is this special case in Elixir that we have to handle. So talking a little bit about Myers difference, editing distance. So basically, I was in a very short description of what's the problem. When I'm comparing 2 things, I should put one in a vertical, the other one in a horizontal way, all the elements that I need to compare. Every time that I have 2 elements that are the same, I should put this diagonal, and every time I start in the left top corner, every time that I have 2 things that are different, when I don't have diagonal, when the 2 elements are different, I should split and walk to the right and down, and this means adding and deleting. And if I find a diagonal, I also can walk straight and diagonal. It's like in one single step, I can walk as many diagonals as I possibly can, but I can only walk one insert or one delete. And I have to walk until I find this corner. And when you find this corner, you have the minimum strings or diff that you want to take. Sometimes it's more than one, but you can pick any of them. In Elixir, this is super easy if you don't know, but there is two functions that do this for you. That's the minus difference. So you just call the function, and you already have the difference. And it works with nested diffs for lists. So it's not like, oh, at least this thing I don't have to worry about, but I actually had to. So it's why I explained it. And how sessions work in the end. So I didn't understand anything about the section. The first thing that I searched was this match fail. The only thing that I know is that I want to handle that error. So I go grab the string and I search, and I find the file where that thing starts, and I start to dig deep from there. So the first thing that I notice is some exception is raised in some point, and this exception will become the message. But how this exception becomes that message? If you see, you have the XUnit runner, and it's catching the errors and saving the errors in a state that later, it was saved where? So the error was saved in this line, and after that, there is something that is a event manager that says that the test is finished, and sends the results of the test to another Gen server. This Gen server will get the result of the test. There is one specific for failures, and we'll call this thing to format the failure. And the format failure will call another function called format kind reason. This thing call another function. If you see here, my session error is back. So I actually think the first time that I found this thing, I was actually just searching for session errors through the Elixir code, and then I found this thing, and then I went back to kind of mount the path. And this calls another function that has format size. So now for the first time I see something similar to what I want. And the format size do the format diff, and also with the result of this is then doing this IO data to binary. I don't know if everyone knows here what's IO data, but it's basically a list of nested list of strings that can be printed. It's printed like a string, but it's way more efficient than a string. And then I have this function in the format diff. It did script and colorize diff. That's the main functions that we will work on. So the colorized diff is getting the diff. Do you remember? If you remember the example that I gave, that is exactly that. If you have equals, if you have delete, or if you have instead, it's putting different colors and then just building a list, a nested list of these things to be printed later. And I have in this edit script is calling the diff and getting the result. If it takes too long, it will return new and will just show everything in red. So the idea is when your tests are running, your test will run. It will know if they failed or if they succeeded, but the errors will be processed later, and there is a timeout to process the errors. So to format the errors, because the diff is quite slow, you have to go deep, and you don't want your test being slow because the diff is super slow. So and this is the output of the diff function. The main function there was called script. So if I do a diff of two arrays, two lists, I have this thing that's it's very similar to that previous one, but there is some strange things. There is like an opening list, there is what's the name? Quotes, there are commas. Why? Because the formatter is just getting these elements and printing them. And this was one of the first things that actually bothered me, because the diff is not showing actually the diff, it's kind of showing the result that you need to print. So you cannot do much with this diff if you want to use for another thing. The formatting and the actual logic is kind of tied together, and I wanted to change this. So my first attempts to the solution was I started with this thing. Was my first code ever, so it's very simple. I just thought, okay, if I have two things that are the same, I would just put same and return the thing. If it's different, I will say what the type of the thing and say it store them so I can later print this thing. But this was a very nice solution. It was working for listed atoms, generally speaking, but it's still very naive. The problems here, especially that if I have a nested list, if I have a nested list or something nested in my results, it's really hard to know if they are different or if they are the same. Because I could have this, like if I have a list, I would have a list and I could have like equals or insertions or deletes inside of the list, or I could have only saves on the list. So I had to go through the whole thing to discover if it was fast or if it was a diff or not a diff there to print red or green in the list. And also there is no minor difference. In that point I came back to what Jeremy suggested, and I was like, it's too hard to implement minor difference because you have pipes, you have plus plus, you have variables, you have pins. I don't want to handle that thing right now because I don't really understand the problem, and it seems very complex to handle. So I worked a little bit more, and this is kind of the first prototype that was working with atoms and lists and tuples, and already had formatting. So the first thing that happened was that I had to do a little bit more complexity, because I will talk a little bit more because I have a screenshot of it, but you can see that I had to add a list terminator to know that the list finished, and I had to stop printing the list. I also added a not match or a match in the beginning of the tuple, so I could know if the whole thing was green or red or just white if without running the whole list. So I also added this error to algebra that was basically getting my matches and computing the output. If you never use it, this function surround, for example, is from inspect algebra. It's a module in Elixir only to print things, so nested structures and all this stuff. So you have methods like surround, join, concat, glue, and you work with these, and you say inspect algebra format, and you say the size of your line. It will show in a nice way. So when you use the mix format, it actually uses inspect algebra to know if all the elements fit in the line or not, if they have to break line and all this stuff. So it's a little bit better than just put a lot of strings together, because it can show the structure nested or not. If you see my test, I have here just a few tests to show what's happening. And it's really hard to distinguish, for example, when I have an empty list and an empty list and a list with one element, and guess empty list with an empty list inside and a list with one single element. Why? Because since I'm representing all the things together in one single tuple, if you see here, I have one tuple with two elements, and the second element has other two elements. And if I don't put that list terminator that you saw, actually the representation of these two things are the same. And then I cannot print the things that I want when I'm doing that. Also, every time that so if you see my structure, my data structure to apply, like the final return is already different from the beginning. And every time that I changed it, I had to change all my tests. And most of the work that I was doing was changing the tests, and that was super exhausted. I was like, I don't want to change this anymore, so I was trying to find a solution for that. As I said, I kept the format separated using algebra spec. This was the only thing that I found that was like, this is working nicely, and I don't think it needs to change. It didn't change it today at the end, so this was really great. And it was missing several cases, especially nested lists. I already was working with lists of different sizes and so on, but not even half of the work was done. I just thought that wasn't prototype at the time. So I went there, and it was like 1 month old, and I was like, hey Jeremy, did you have any success? I had a prototype working. If you don't want, if you're not working, I have something to send. So he said like, yes, I'm doing it. I'm happy with the work. And actually, when I look at in his pull request, he was having kind of the same ideas. I think he was a little bit behind me, but he was in the same direction. That's fine. I will keep working just to see if I get somewhere, but I will, probably he will finish whatever he's doing. But now I'm curious, I actually liked the problem, so I was more by curiosity continuing. So I will talk a little bit what was the final solution in the end. So this was measured last week by my surprise, because it was open for like 4 months. And there was no comment, so last week was measured. I'm happy, so you can already try it. It's in the last version of master. And I will talk a little bit how I solved the problems that I raised to you. So the first thing that I talked about Myers difference, and I gave up using Myers difference. But at some point, and also because of Jeremy's pull request, he did a pull request, and Jose Valim did a very long discussion there on how things should do. I said I will give a little bit another try to the Myers difference to see if I can do that, because it's really useful. So what I did was, when I receive a list that's like this, that's very complex, for the Myers difference, I need a simple list. So what I will do is that I will parse this list, break down in a list that's I don't know how to say it, it's flat, and I will break down the improper element, and I will save all the operators so I can rebuild this when I need to show to the user. So if you see here, the first thing that I say is like, there is a plus on the operator on index 3, then to the left side I have a pipe operator on index 0, and it goes until you find new, and new means that I finish and it's the end of my list, and then you append the element back. So I could just take my list, do the Myers difference, and get the result and build back again the pattern that I did. So this was what I did in the end. So and this is really nice, because it's like, if you see, I went through a solution that was harder, and I had to do a lot of stuff to go back to a solution that was actually really simple and really easy to do. Really easy is very strong, but the idea is easy. I had to, like, if you see Myers difference in the list module, it uses pattern match to do the comparison. So I had actually to copy all the Myers difference. I didn't even need to understand the algorithm. I just changed the comparison. So if I get 2 elements, I will call again my function to compare and get the result and decide what to do with the result. Because if I can have a variable on the first element and a number here, and I have to say that, I don't know, if I have x, I have to check if x is equals 1 or not, if the value was already there. It's a little bit complex. So I had to change just this small thing, and it was working. Maps in the end, so when you compare with true thing, with equals, you get the key, like the green on the right side, and when you compare with assigns, you don't get anything on this side, so you just see the difference in the map. I had to add context to understand when you're doing one, when you're doing another, but it's working. The data representation. This one I think was the hardest thing. I had to go back and forth a lot of times. I actually, so in the final solution was basically splitting the left and the right side. Instead of trying to do them, to represent them together, and when you have different sides of things, putting like terminators and this stuff, I just broke down left and right. That was actually very obvious. And I extended Elixir AST. So if you have, for who doesn't really know metaprogramming Elixir, if you do code, you get the AST of the elements. If you do code for literals that we call atoms, numbers, lists, you just get the same thing. If you do code for a tuple, for example, you get a 3-element tuple that represents the tuple. And if there is a special case that a 2-element tuple is also a literal. And if you do with a macro, for example, it's the same thing. And the element in the middle of the tuple is metadata. So what I did was just like every time that I have a diff, I insert or a delete, I will just say diff true, and I know in the left that is remove, in the right that's delete, and I can show these things. If I have a literal, because they don't have metadata, I can create a block tuple and just put there the element. The block tuple doesn't do anything for the compiler. It's like when you have multiple lines inside of something. So it will just parse all the lines, and with one element is the same thing as the element. And for strings and numbers also there is a special exception. So I have also to save the type of quotes that you use in the string, if it's simple or double quotes, so I can print back in the end. In the end, so this is basically the final thing. If I do a diff of something, here I have, I forgot to put the list here, but this is A plus, it's a list containing A and piping to B plus C, and you can see here that there is a diff for the C. So I'm comparing a list. It was let me put back because it's easier to see. So it's this thing here, and I'm comparing to a list ABE. In the end, I can say that the C is different and the D is different, and you can see that A, B, and E are still the same, and I can print the final difference. And there is a special case for macros. So when I span macros, so macros I have to span. I cannot compare 1 to 2 because I don't know what's 1. I have to actually expand my macro 1 and get the value. But when I do that, I lose the macro 1, and you don't want to see the left side here written 1. You just want to see 1 that was your macro in the beginning. So I had to do a small trick that was to expand the macro and put the function inside of the metadata. And then this was measured, and someone already said that there were a few issues. So the tuple, for example, I was comparing the tuple like a list, and you can see if you have a OK over tuple, it's a little bit weird. It's not the best tool. So I already changed the implementation to actually compare one by one element. So the first solution that I set to list, I'm actually using for tuples, and tuples don't behave like lists anymore. And the next steps. Basically, I have to implement the diffing for guards, and I have to use the diff in the asset receive. I actually already did the first one. I will do this soon, and I hope it will be helpful for everyone. using the language when it's doing some diffs. And this is just this is actually the diff that I didn't put. You see, if now when you do the diffs, you can see just whatever is different when you're doing your test, when you run your test. Thank you. Does anyone have any question?
Maybe on your pull request, did you have a lot of back and forth with corrections or questions?
So my pull request is specifically not. So if you see the pull request before, because this Jeremy, he opened 2 pull requests, and there was a lot of discussions in this pull request, and I got all the discussions that were happening in lab, and I was fixed my pull request on that thing. And I think because it was open too long, Jose Evelyn did some small changes. Just like he simplified a little bit how I do the blocks. Like if you see, I was adding this block diff container, for example, and I was adding diff container number for numbers, for example, and he removed this and just use a block. And like there is some simplifications. If you see, the functions to do that are a little bit simpler, but he didn't ask me to change. He just changed it because I think were very small. So he just added a commit and push it directly. Usually there is a lot of back and forth. To be very honest, like I did a lot of contributions. Most of the contributions that I did, I start with a solution with like 200 lines, and in the end there is like 5-line solution. And it's really, like you learn a lot in these things, how to simplify and how to think way simpler in the things that you try to solve. So actually, this one didn't change much, but my experience is that usually it changes a lot when you submit. Yeah. Anyone else?
I have one question.
Yeah.
So you mentioned that it took you roughly 2 years.
Yes. It's not, so I forgot to say some things about this. Yes. It's actually like, it's not 2 years like that I was working all the weekends. Yeah. It's just like I started working, and then you get to these phases that like I give up, it's too much, it's like too much, and like I spend like, I don't know, 6 months without doing, and then I go back, and then I work like 1 month or 2 months, and then I give up, and then I go back, like you have this back and forth, you give up of the thing. But I think when Jeremy actually dropped the pull request and he said like I don't want to try anymore. Then was when I actually started. I worked a lot. I worked a lot, like I think 1 month last year and during the Elixir conf mostly this year. Yeah, I was like doing this thing here. Yeah, but in the end, like when I had this, like when I solved all the issues that like I had these ideas and I was like, oh, this is the solution, was actually quite easy to go. But the biggest problem was to find the proper data structure to represent my problem. And I think this is actually one of the hardest things in any solution that you do. Like I had to go and come back a lot of times, and I gave up several times because every time that I thought I found the solution, I was like, oh no, when I have to do a diff of these and these, it's actually the same as before. So I was printing a completely wrong thing. And I was like, okay, I give up, yeah, so it was quite a journey, but not a very continuous journey. Yeah. Anyone? No? Thank you.
So should be, I guess, ready. Yeah, so if you still have idea, if you want to give a lightning talk, then please, during the next 20 minutes, come to me and tell me. If not, then it's fine as well. So please enjoy the food. Thanks.